My name is Narayana. I'm a professor of radiology and also director of MRI research. I'm the vice chair in the Department of Radiology. I came to University of Texas Medical School in 1983, believe it's a long time. My basic training was in physics and mathematics. So I did quite a bit of very hardcore physics problems. But the problem with that is many times you don't see the application right away. So then I heard about the imaging program at UT Health Science Center, particularly in the medical school. I know that strong mathematics and physics background are necessary for imaging. And also I felt that I can make some contributions which translate into some practical applications, which could help in better management of patients, in developing new techniques and faster techniques. So originally I joined Dr. Jonathan Ophir, late Dr. Ophir, in ultrasound imaging. We published quite a few papers in looking at ultrasound, particularly focusing on attenuation of ultrasound and the nonlinear effects. Then Dr. Harris, who was the chair of radiology at that time, he wanted to start a new imaging program. So he recruited Jean Dallaire to head the program. Jean Dallaire approached me and asked me if I'd be interested in joining the MRI imaging group. That was the time when MRI imaging actually was coming up. And we wanted to do certain things. There are no commercial instruments available. So Dr. Dallaire, along with the other members of the group, decided to design and build a new scanner dedicated for animal research. So then we were actually a group of 4, myself and Du Jensen, Victor Tong, and Bill Bray. We all were given separate chores. For example, my focus was on radio frequency coil development, and others focused on different aspects of the scanner. So we bought a magnet, a 2 Tesla magnet, which is 30 centimeter bore, which can accommodate small animals. And we started building the console and all the other electronics. But it's sort of, I recall with some fondness, this computer we used was a DEC microcomputer. It had 2 megabytes of disk space, which was large, and about 64K memory. And by today's standard, a laptop does much better than that. We paid, I believe, about $150,000, and it required special air conditioning because of the heat generated. So we used to get an image, change the disk, and start all over again. It was fun, frustrating, but in hindsight, I think we learned quite a bit. So we finally we tested the scanner, I believe in 1985 or 86, on Christmas Day. Everything was working on phantoms. So the next thing was to do in vivo image. So the next few days we put an animal, small cat, and got the image of the cat brain. That's one of the most exciting moments, to see an in vivo image of an animal on a home-built scanner. Then we did quite a bit of work on that one, published a few papers. And unfortunately, this scanner decided to quench. What happened was there's a O-ring which was holding the vacuum. It's about 5 cents or a dime. That O-ring gave away and the magnet quenched, and we had to call the manufacturer of the magnet, Narayana, and we started, we brought the magnet back again. So we ran the scanner for a while and published again number of publications. Then one of my associates was working on the scanner alone that night, and he forgot to turn the gradient supply off. So when he came back in the morning, the gradient actually was overheated. It melted, distorted the bore, so the magnet has become almost unusable. So again we had to call Narayana, and finally we managed to fix. So in the meanwhile, Jean Dallaire left to start his own company. So Dr. Harris asked me to take over. He was head of the MRI group. And so we found some money through a small funding. And so I decided to go for a different gradient coil. And we bought a gradient coil from a company called Sims. And we ran the scanner. So this went on for a while. And in the meanwhile, we did quite a bit of work in the development of new coils, new algorithms, new imaging techniques. Yeah, it was pretty exciting time. Believe it or not, we used to come very early in the morning and probably leave in the midnight. We used to work on weekends, perhaps also on New Year's Eve and Christmas Eve. But that's what research calls for. Finally, we also bought new gradient system. I was getting a little bit tired of maintaining the scanner because it's taking too much of time away from research. So I applied for what's called Shared Instrumentation Grant, which is an NIH-sponsored program. So I got the money. So we bought a magnet and a scanner from a company called Broker. The scanner was actually located in the basement of the main medical school. And we did again establish quite a bit of collaboration. And we started working. So then came Allison, 2001. So I got a call around 4 o'clock in the morning from the university that there may be some water accumulation in the MRI suite. So I tried to come. I live in Bel Air. So the Bel Air Boulevard was completely flooded. So it was almost impassable. So anyway, I took circuitous route and finally reached, only to find that the magnet room was filled with water. Because of safety and health concerns, they wouldn't let me go into the scanner room. So what also happened was, at that time my office was on the 6th floor of the medical school. So they are going to renovate my office and that area. So they asked us to move all our computers and lab to the basement. So we had about a dozen computers with software developed over a period of, about 10 years, 12 years. When I came here, all the backup copies are also in the same basement. So then we came here, I found the room to be filled, but I couldn't get into the room because of health considerations. So we waited for a while, so ultimately they allowed me in, went and saw. the magnet room was completely filled with water. But the funny thing is the magnet was still ticking, as the Timex commercial says, took a licking and keep on kicking or ticking. But in a short story, so at that time I thought maybe rather than rebuilding the program or rebuilding the scanner and establishing the MRI lab, maybe it's a good time for me to leave. So I got numerous offers, unsolicited offers, because people knew that our lab was damaged. So finally Dr. Bhuya, at that time the dean of the medical school, called me and said that, don't worry, I'll support your MRI program, don't leave, continue the MRI program. I said okay, because by that time we already established number of collaborations within investigators, so I didn't want to start all over again. So then I applied to NIH for what's called high-end instrumentation grant to purchase a new scanner, and the NIH fortunately gave me the money. It's $1.5 million to purchase the scanner, and Dr. Bhuya agreed to pay for the siting cost, which is close to about $500,000. So at that time we were promoted from the basement to the first floor or the ground floor of the medical school, and we established this one and we ran the scanner for quite some time. It's still running, fortunately. And in the meanwhile, Hermann Memorial got a clinical scanner, 1.5 Tesla GE scanner. So I, Dr. Polanski and Dr. Butler, who both are neurologists, we decided that we are going to start some human program, clinical programs, clinical research, that is to say. So we started working on the scanner. So we developed quite a bit of technology. We used to come here on weekends because that's the only time we were allowed to work. The scan itself was in a trailer. So at that time I learned quite a bit about clinical scans and about the clinical problems, and everything went fine. Then after Allison, the cyclotron facility was damaged completely. So we got some money, and at that time I proposed that we start a human MRI program, because with Hermann scan there are quite a few restrictions. Even weekends, if they had an emergency, they used to kick out. So finally it was decided that we purchase a 3 Tesla scanner, established scanner. So we bought a 3 Tesla Philips scanner. Again I applied for NIH grant under shared instrumentation. I received about $500,000. And then the school put the money for siting and paid rest of the money, supplemented this one. So that MRI program, the Philips scanner, we upgraded it twice since then, and it's still running. So that's really the story of the MRI program at the medical school. With the MRI scanner at that time at state of the art, we established quite a few collaborations with various departments, neurology, psychiatry, neurobiology and anatomy, so on and so forth. And I think we provided quite a bit of support to a number of investigators who were able to generate extramural funding through NIH and other sources. So for my work, I've been funded by NIH and Department of Defense for the last continuously for 30 plus years. So I must say that I'm lucky. and this is what the MRI program is here. The question is, while I was here, I got numerous offers, some of them extremely attractive, but I decided to stay here simply because of the collaborators and excellent environment the medical school has provided. And I'm glad that I stayed back. And I think that I have been, not to boast about myself, pretty successful as a scientist, as an investigator. There are a number of things. As I said, the first thing is when we generated the first image, in vivo image of the cat, looking at the brain, gray matter, white matter. It was pretty exciting. And one of the exciting things was, at that time, I started the graduate program in the MRI research. MRI research was at that time at its infancy. So fortunately, I was able to attract some of the best graduate students from Graduate School of Biomedical Sciences, or GSBS. And we developed quite a bit. I received Presidential Scholar Award. I was recognized by the Academy of Radiology as a distinguished researcher. I was also elected as a fellow of ISMRM, which is our premier society. And many of my graduate students went on to become leaders in their own right, different universities. And those are some of my proudest moments and proudest accomplishments. I think medical school has been very generous to me. In other words, in supporting the MRI program, in providing funding whenever I needed it. This support, I really couldn't complain. I'm really very pleased with the support extended by the medical school. And meanwhile, medical school also expanded quite a bit. I think we almost doubled the research space, and we acquired very sophisticated instruments like MRI and cryo-EM, and they developed the South Campus, which provided a lot more space. And I think the graduate program has probably attracted some of the best graduate students, GSBS. So I'm really proud to be associated with the medical school. We recently we recruited 3 very bright MRI scientists in the group. So now what we are doing is, you may have heard about the precision medicine. We are applying the same concepts to precision MRI, whereby we customize the scans based on the patient physiologic parameters. In order to do that, we have to develop quite a bit of software, which is fast. And since it's a real-time processing, we started a collaboration with the TAC, that's Texas Computing Center at Austin. So we basically interfaced our scanner to upload all the imaging data to the TAC computers, and then crunch the numbers almost in real time and download the images onto the scanner, so that everything takes, I think, 2 to 3 minutes. So I think it has quite a bit of future, because we can actually, if there's any problems with the scans, rather than recalling the patient, we can detect in real time and tell the technologist to rescan the patient, because there may be some problems with the images acquired. Then we started artificial intelligence, what's called, I think, for deep learning, for processing and for predicting the prognosis of the patient based on the MRI imaging characteristics. It is still a long way to go, but I think made a start. I think these two avenues, I think, probably are the future of the MRI to some extent. I mean, the number of other aspects, but these are some of the important aspects. Because of my work, I have been invited both nationally and internationally to give talks, to serve as a visiting professor, and sit on various grant panels. That's my story here at UT. I want to acknowledge my group. Even though I get the recognition, the fact is most of the work is done by them. I'm merely an ambassador, carrying their, presenting their work. In particular, Rifat Gaber, who is a very close collaborator of mine, and Khadra Hassan, and Shushmita Datta. These are the three faculty members I recruited. So I'm proud of their accomplishments and proud of the program.